Hopefully you noticed that today's video came after you did the on your own problem. So if you didn't notice that, stop the video, go back and attempt to do on your own problems 1.11 and 1.12. Try to do those on your own and then come back and watch the video after you've tried to do them. There are 2 points that he makes that I want to go over because they may really be messing with your brain and you may be going, oh, I don't understand how he gets this. The first of these is, well, first of all, the slope of a velocity time graph is going to be acceleration. And so anytime you have a velocity time graph and you see an inflection point, before we said that on a position time graph, that inflection point meant that the object was changing direction. However, on a velocity time graph, these inflection points mean that the object is either speeding up or he's slowing down. So here, the velocity is going in a positive direction, but here he's slowing down because he's going from 120 meters per second to 100 meters per second to 80 meters per second. So here he's going, the object is slowing down. Here the object is speeding up. Here he's slowing down again until he gets down to here, and then we'll talk about this piece here in just a second. So first question was, how can the acceleration be 0 when the velocity isn't? How does that happen? Well, let's say that you're driving a car, and let's say that you're slowing down, and you don't come all the way to a stop, but maybe you've got your foot on the brake. And let's say that at time equals 6 seconds, you take your foot off the brake and you put it onto the accelerator. Okay? At that instant in time, from the time when you don't have your foot on either the accelerator or the brake, at that point, the acceleration is 0. You're not pushing the car to go faster. You're not braking the car to go slower. So right here at this point, the acceleration is equal to 0, but the car is still moving with a velocity of 40 meters per second. Okay, so remember that acceleration means a change in velocity. And at that point, you're just coasting and you're not changing your velocity any. And so keep in mind what the definition of acceleration is. Acceleration is a change in velocity over time. So if the velocity is not changing, acceleration is going to be 0. Similarly, if you are traveling in a straight line at a constant velocity, maybe you're constantly going at 10 meters per second, at that point you don't have any acceleration either because your velocity is not changing. You want to keep in mind that the sign of a velocity is based on the direction. A positive sign for your velocity means it's going forward. A negative sign for your velocity means it's going backward because it's related to displacement. So if you have a negative acceleration, it can indicate direction. In fact, it does indicate direction, but it doesn't always coincide with speeding up or slowing down, as we had talked about before. We said that if acceleration and velocity have opposite signs, then the object is slowing down. If they have the same sign, they are speeding up. So if I look at this graph here, again, this is supposed to be the same one that's in your book. From time equals 1 second to time equals 6 seconds, the object is slowing down. From time equals 6 seconds to time equals 12 seconds, the object is speeding up. From 12 seconds to 16 seconds, the object is once again slowing down. And here, the velocity at this point right here, your velocity is 0. So at this instant in time, the object is not moving. Now when I get down here, my velocity is actually negative, and so that means that the object is now going in the opposite direction from the way it was going before. So if I look at this, if I calculate, this is a relatively straight piece of the curve right here. So if I want to calculate the acceleration here, the acceleration is going to be the change in velocity over the change in time. Well, the velocity at the end of this piece is about negative 50 meters per second. So I have a negative 50 meters per second the initial velocity was 0, so it's going to be minus 0 meters per second over a period of 4 seconds, 5 seconds? Yeah, 5 seconds. Period of 5 seconds, according to what he does in the book there. Okay, so at that point, then, I have a negative 50 divided by 5. That should only be 4 seconds. Sorry, we're going from 16 to 20, so 4 seconds. So negative 50 divided by 4 is going to give me, what, about negative 12 and a half meters per second squared. And so, yes, my acceleration is negative, but my velocity was also negative. And so what that means is from this section to this section of the graph, my object is actually speeding up because he's going from 0 to negative 40. Again, that just means he's going in the opposite direction. And since the velocity is negative and the acceleration is negative, the object is speeding up. So what that tells us is that as I am going away from this x-axis, my object is going to be going faster. So here I'm going away from the x-axis, the object is speeding up. Here I'm going away from the x-axis, the object is going to be speeding up. And you may be going, I cannot get a picture in my head of how this works. Okay, so let's, again, position yourself in a car. You're slowing down, you've got your foot on the brake. Maybe you're coming up, there's a car in front of you and you don't want to hit it. So you're slowing down at time equals 6 seconds. You take your foot off the brake and you switch to the gas pedal. And so you push on the gas and you go faster, you go faster, you go faster. At time equals 12 seconds, you're going to again switch from the gas pedal to the brake pedal. At 13 seconds, so about right here, you suddenly get the bright idea to put the vehicle into reverse and floor the gas. Please do not try that in real life. It's horrible on your transmission, so don't actually try that. Okay, but if you would do that, the vehicle is going to continue going in one direction until it gets to a stop, and then it will start going the other direction. Okay, so at that point, you're going to keep going forward. So you put it into reverse, and you keep going the same direction until you actually get to a stop, and now you're going to start to go backwards once you get here. At that moment in time, from the time when you're going forwards to the time when you start going backwards, at that point in time, your velocity is 0, and so therefore your velocity can be 0 even though at that point in time your acceleration is not, because you've still got your foot on that gas pedal all the way to the floor. Okay, so as you go further away from the x-axis, you're speeding up. As you go closer to the x-axis, you are slowing down. And so again, keep in mind that when your acceleration and your velocity are both the same, have the same sign, you are actually going to be speeding up. So acceleration can be 0 when velocity is not. Velocity can be 0 when acceleration is not. Two really important points that you need to cement in your head well.